Hello and welcome to the second video about Chapter 7. Chapter 7 is about forecasting in the supply chain. In the previous video we crossed the introduction into forecasting into the supply chain, what's it for and what are the main characteristics. In this video we are using the static method for forecasting. As mentioned earlier, we also have the adaptive method of forecasting, which we will cross in later videos. This method, the statistic method, works with the static component. The static component, as mentioned earlier, consists of the level of the trend and the seasonal factor. If you got trouble with that, please go to the first video and see that video again. Level plus trend times the seasonal factor, if we write that down in a formula, we come into this kind of formula. The F is the forecast for period T, so period 1, 2, 3, 4, 5, 6 and so forth and so on. L is the estimate of level at period 0. It can also be L1, L2, L3, then it is the level for period 1, 2, 3. The estimate for the trend is the T, and the S is the seasonal factor. So the seasonal factor within, for example, the quarters in a year. What we see here is that F is TL. That's important. Please keep that in mind for we can work with it. In the book Supply Chain Management of Chopra, we used the example of Tahoe salt. Tahoe salt has years from 1 till 4 and 4 quarters in each year. In this case, the time series starts with 1 till 12. Please mention that the first quarter of the first year is non-existent. Here we got the demand, and the demand is the actual demand which was present at year 1, quarter 2 was 8,000 units sold by Tahoe salt. Now we're going to see what would happen if we are using the static method for forecasting in this example. What we saw in the earlier table is that Tahoe salt has a seasonal factor. The seasons work in this way, and as you can see, a season has 4 quarters, as there is 1, 2, 3, 4 quarters. That's important to keep in mind that P, periodicity, is 4. Here we see it again, 1, 2, 3, 4, and here 1, 2, 3, and the season tells us that the potential is high, that it goes down. What we can also make up out of this graph, that there potentially could be a trend, an increasing trend, as the highest points go up and the lowest points also go up. But now we're going to see whether or not that is the case or not. Because we have to estimate the level, the trend and the seasonality. That's what we have to do. First, we are for that to do. We need to normalize the demand in the years. How we do that? For P is 4, because we got 4 quarters, and afterwards we got the same seasonality again. So in this case, for P is even, 4 is even. So if we want the dt, the average dt, to be calculated, we use this formula. In this formula tells us that dt for dt minus p divided by 2, etc., 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 and so forth and so on. How does that work with all the timing? Let's put this on our whiteboard. So we got dt is dt minus p by 2 plus dt plus p divided by 2 plus we sum I is t plus 1 minus p divided by 2 and t minus 1 plus p divided by 2, and that all to dt, and this whole we divide by 2p. That's the whole formula we use for in the first step to estimate the trend. So, if we want to come up with the average demand for example, period 5, then we have to take into account d5 minus p. P is 4, as there are 4 quarters. 4 divided by 2 plus d5 plus 4 divided by 2 plus I is 5 plus 1 minus 4 divided by 2 till 5 minus 1 plus 4 divided by 2. And this all is 2d5. And this all we divide by 2, 4. If we rewrite this formula, what would happen if we do so? Then we got d5 is d5, no. d5 minus 4 divided by 2, so 2. So that is d minus 2 is 3. Plus d5 plus 2, so that is d7. Plus I is the starting of the, tells us that we have to start the summing of it. 5 plus 1 is 6. 6 minus 4 divided by 2, so 6 minus 2 is d4. 4. 5 minus 1 is 4, plus 2 is 6. And what do we do? What do we sum? That is 2 times d. And this whole we have to divide by 8, as 8 is 2 times 4. So if we would rewrite this formula, we would get d5 is d3 plus d7 plus d4 plus d4 plus d5 plus d5 plus d6 plus d6 and this whole divided by 8, as there is 1, 2, 3, 4, 5, 6, 7, 8 different demands. This is how we calculate the average demand for period 5. So if we want to calculate the average demand for period 5, we use this this formula and this working of that formula. If we would use, if we want to average the demand of period 6, we do exactly the same, but then for period 6. And this is important because we want to see whether or not it is possible to estimate the level and the trend, as mentioned earlier in our PowerPoint. In the PowerPoint itself, we also refer to the Excel file. The Excel file is also available on the electronic learning environment, and the Excel file available there calculates for us the deseasonalized demand. The deseasonalized demand we calculated there for period number 5. We can also do that for 4, 6, for period 3, 4, 5, 6, 7, 8, 9, and period 10. And from this deseasonalized demand, we have to make a regression analysis. So our static method works in 3 steps. The first step is deseasonalize demand. The second step is regression analysis. And the third one we cross in a later slide. That is seasoning. So now we have to use the regression analysis. Regression analysis you can do with Microsoft Excel. If you want to know more about regression analysis and all the components in regression analysis, please to refer to statistics. That's not a topic we're going to cross in supply chain management. We only use it, and if you want to know more about it, please refer to statistics itself. So we have to do a regression analysis based on the deseasonalized demand, and if we do so, then we will come up with an answer to this formula. D average T is level plus the trend times the period. As we see that the actual demand is seasonalized, the deseasonalized demand has a trend to go up, and in regression analysis we come up with how much the trend actually is. The last step is estimating seasonal factors. So that is the last step. Estimating seasonal factors. Estimating seasonal factors, we first have to calculate the seasonal factor for each and every quarter in a year in this example of Tahoe salt. How do we do that? We take the actual demand and we divide it by the deseasonalized demand. So B2 divided by C2. The deseasonalized demand for the second quarter in the first year, or in this example, the first period, is 0.42. And that is what we do for all the seasons. Now, the second step in the estimating seasonal factors is a very obvious one. As mentioned earlier, we have 4 quarters in a year, and a year has a season in this case. The second quarter in the first year is the same as the second quarter in the second year, and is the same as the second quarter in the third year. Those are all in the same season. So what you do is you take the 2nd, the 6th and the 10th seasons, and that is what you divide by 3. If you have more seasons available, then you divide it by 4, 5, 6, 7, 8, and so forth and so on. You add them up, divide by 3, and so the estimate seasonal factor for the second quarter is 0.68. So if we want to calculate the forecast for period 13, 14, 15 and 16, we use again the same formula what we crossed in earlier slides. In earlier slides we saw that level plus the trend times the period, and this times the seasonal factor for that particular period. From regression analysis we came up that the level, so the starting point of the forecast, was 82,439. The trend is 524. We do this times 13, as we are now in the 13th period. So 18,439 plus 13 times 524, and that whole bunch, as it is between brackets, times 0.47. Times 0.47, please relay that to the seasonal factor. This comes up with a forecast in period 13 for 11,868, and in the forecast for period 16 is 44,794. This was the way in which we calculate the static method. Through the static method. The static method is also important for the second series in forecasting methods, and that's adaptive forecasting. In coming videos we will cross adaptive forecasting in four different methods.